Oh hey, I didn't see you there. Have you ever ordered a layered latte and wondered how those layers were formed? Let's take a look at how this happens and how you can form your own at home. In Newtonian fluid, the phenomenon of double diffusive convection allows distinct layered patterns to be formed. Double diffusive convection is a combination of temperatures and density gradients, where hotter liquid heats up a section of cooler, denser liquid, in this case the milk, causing it to slightly rise, and the cooler, denser layer chills out some of the less dense layers, such as espresso, causing it to sink. This process creates convection cells, which flow horizontally, not vertically. Layered in a layered latte are formed because the poured milk is added in sheets, rather than mixing the layers already in the cup. This is accomplished through slow, unperturbed motion called laminar flow. If we were to have a turbulent or fast flow, the layers of milk and coffee would mix. Let's set up the problem. We can calculate the pouring velocity of the milk needed to attain a layered latte if we know the height at which the milk is being poured, the pouring angle, and the fluid properties of the milk. We're going to make the following assumptions in this video. Assumption 1. Steady state flow. 2. Downward liquid inertia is balanced by buoyancy force. 3. The only velocity is in the z direction. 4. No external pressures are applied. Viscosity of the milk was calculated using the relationship that the ln of u is equal to negative 8.9 plus 0.1 times f plus 2721.5 divided by t. Momentum is conserved, so we'll start with a Navier-Stokes equation. We will eliminate all terms on the left-hand side with assumptions 1, 2, and 3. Then cancel out the pressure term using assumption number 4, and then the next terms that are remaining with assumptions 2 and 3. Let's start our first set of calculations. First, we'll find the initial pouring velocity using the falling film case. Next, we'll be using average initial pouring velocity to calculate the terminal velocity at different heights. We will use the Bernoulli's equation to find the velocity because it relates the velocity to the pressure and height. By plugging these values back into the Bernoulli's principle, we are now able to solve for u and u initial. We can see that the velocity depends on the height from which you pour it in. When pouring at a height of 10 centimeters, the terminal velocity becomes 1.4 meters per second, and when we're pouring at the height of 20 centimeters, the terminal velocity becomes 1.98 meters per second. The general concept of double diffusive convection has important implications outside of coffee shops. This phenomenon can also be used to create layered gels that could be applied in tissue engineering. In closing, we want to thank Sunny and Brian for making this video possible. Thank you.